Okay, the last part about triangles is proving what we call congruency. And if we prove congruency, it means we prove two triangles are equal. Congruency means equal. So you can prove congruency between triangles by using the following three theorems. The first theorem is side, side, side. If two triangles have congruent side lengths, then the triangles are congruent. The next one is side angle side. If two triangles have two sides and the corresponding angle, that means the angle that is created between the two sides, then the two triangles are congruent. The same. They're the same triangle. The next one is angle side angle. The last one. And this says that if two triangles, if they have corresponding angles, segment, angle, then the two triangles are congruent or the same. And we're going to apply them. So it's side, 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 side angle side, and angle side angle. I like to write them down when I do my homework. When I do my proofs, it's actually called. And I like to write down, okay, I'm either going to use side, 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 side angle side, or angle side angle. That's what I'm looking for. Which one of these are going to be it? You can't just say, hey, triangle NMO is congruent to triangle, what, PRQ. You can't just tell me that. You have to, in this lesson, prove it. And proving it is using the congruent statements. So looking at this, which one should I use? Side, 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 side angle side, or angle side angle?
Side angle side.
Right? Because I have a side, I have an angle, I have a side that are congruent. So my best advice is to write that you're going to use side angle side vertically. That's the biggest point of confusion that a lot of 10th graders or 8th graders that take geometry or 9th graders that take geometry, the biggest point of confusion, they don't know how to start. What I suggest is look to see what can you use, write it down and go from there. Okay, so side. I'm just going to start with the side. I'm going to say segment NM is congruent to segment what?
PQR.
PR. Segment. We're not angle. Segment PR. So segment NM is congruent to PR. I just said that. I can't say their sides. I have to show that they're congruent. Now I have an angle. I need to show that these angles are congruent. So I'm going to say angle NMO. So I'm telling my eyes to go from N to M to O. That's the angle M. Is congruent to angle PRQ. Okay? So now I've shown side and an angle. I have to show the side. So then I can say segment. Let's see, I always start with this left triangle. So segment NMO is congruent to segment RQ. I am not done. Proofs always have that final statement, like, booyah, it's done, I proved it. What you say is, therefore, triangle, I'm going to call it NMO, is congruent to triangle PQR. By SAS. So I proved the theorem that many people have proved this theorem. So I used a previous proof to prove that these two triangles are the same. By SAS, and then proofs end with a little box saying done. It's like a stamp of approval. You're done. Okay, looking at this next example, I'm just going to minimize this, this first one here because the letter, that's just too big. So let me group this. I need this space. Okay, so anytime I look at it, where's my starting point? That means which theorem am I going to use? Side, 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 angle, side, angle, side, angle. So I just look to see, okay, what do I know? I can't assume anything with proofs. They have to give it to me by showing congruency with, notice how they showed the dashed lines. That's saying these are equal. You can't just assume it. They have to have it there to support it. So what do I know? I know that I have an angle. I know that I have this side because they share it. So if they share it, clearly it's the same, right? And I know I have this angle. So it would be angle, side, angle. And now I start proving. I like to go from the top down. So I'm going to prove this angle or write the congruency statements for the angles. So I'm going to say angle WAB is congruent to angle XAB. The angle that I'm talking about is always smooshed in between. Now I'm going to talk about this segment. And I call it segment AB is congruent to what? AB, because it's shared. It's a transversal is what we like to call it. Segment AB is congruent to AB. Now my last angle. So I'm going to say WBA. Angle WBA, there could be multiple ways that you write this, is congruent to angle XBA. Okay? Therefore, triangle, and I'm going to say AWB, is congruent to triangle AXW by angle side angle. Proof is done. Okay? Proof is done. All right. Last one. So again, I can't assume anything. They have to give me what's congruent right away. So what do they give me? They give me a side. They give me a side. Whoops. And they give me another side. So what can I use? What can I use? Thank you. Side, side, side. All right. So it's hard to see because it's such a dark picture. But I'm going to start picking a side. So I'm going to say, let's see. Let's do F. FJ, the one with the 3, segment FJ, it's a segment, is congruent to segment FG. And then I'll say segment JI is congruent to segment GH. Now notice how I'm using my writing utensil to help my eyes know where I'm at too. It's a strategy that you can use. And then segment, I need to go from I to F, right? Segment IF is congruent to segment HF. Therefore, triangle FJH is or FJI is congruent to triangle FGH by side, side, side. Done. Proof is done. Okay? All right. That is the end of your geometry unit.